So then we go to part B, because once we standardize our sodium hydroxide, we can also use that NaOH to titrate vinegar. And this is another analytical experiment where we're going to find out how much acetic acid is in vinegar based on the standardized sodium hydroxide that we know the concentration of. Right? So first thing in this part, it asks you to calculate the volume of vinegar that will be neutralized by 25 mils of standardized sodium hydroxide solution. And in this case, the vinegar, we have to assume that the density is 1 gram per milliliter. And if for most vinegars, it's about 5% acetic acid. So it's the acetic acid in vinegar that's being neutralized by the sodium hydroxide. So you first have to calculate the moles of acetic acid. Right, so if you're given that it's 5% acetic acid by mass and a density of 1 gram per milliliter, and we assume 1 gram of vinegar, then 5% of that 1 gram is going to be acetic acid. So we can say that 1 gram of vinegar contains 0.05 grams of acetic acid. Knowing that, we can find the number of moles of acetic acid, right? 0.05 grams divided by the molecular weight of acetic acid gives me 8.3 times 10 to the third moles. So now we can conclude that 1 ml of vinegar, right, contains 0.008 moles, and it has a concentration of 0.0008 moles divided by 0.001 liter, because we're dealing with 1 milliliter of solution, right, or 1 milliliter of vinegar. And so now we can say that the concentration of this particular sample is 0.833. So when it asks how much vinegar is necessary when you have 25 mils of your 0.16 molar NaOH solution that you got from the last experiment, then we can use the dilution equation again, right? This time, though, we're solving for volume and not molarity, right? So if you look at the equation, M1V1 equals M2V2, so you have 0.16 times 0.025 liters, that's the sodium hydroxide, and then you have 0.833 molar acetic acid, and then times an unknown number of liters. So we're going to figure that out. So we'll just solve for X. It should calculate out to 5 milliliters of acetic acid, right? So if you know that, then we can set up the titration. So here's how acetic acid reacts with sodium hydroxide. This is acetic acid on the left. Sodium hydroxide, the base, is on the right here. And then they react again through a proton transfer. And if you note here, there's also a 1-to-1 mole ratio of H plus to OH minus. So let's look at the mechanism. So now it's the same exact mechanism, just a different acid, right? The sodium hydroxide, the OH gives a pair of electrons to the proton, and the OH bond breaks, those electrons go back to oxygen. And so now you have this acetate salt plus water, and we can say that acetic acid is a monoprotic Bronsted acid. Monoprotic meaning it gives away 1 proton, and it reacts with sodium hydroxide, which is a Bronsted base, and it does so through proton transfer. All right. So here's the same setup for the vinegar analysis. You're going to have a vinegar solution, and you're going to titrate in sodium hydroxide that you know the molarity of, which is 0.16. And if you know that and it's accurate based on your standardization, then you should be able to figure out what the percent by mass of acetic acid is in the vinegar solution, right? And so that endpoint, again, is going to be signaled by a color change, because we're going to use phenolphthalein as our indicator. So you're going to repeat that experiment twice on vinegar to determine the average percent by mass of acetic acid in vinegar. So what have we learned from this? We've learned that standardization is accomplished using a primary standard to accurately determine the concentration of a given solution. We learned that titration uses an analyte and a titrant to determine the concentration of the titrant. We also learned that titrations require the use of an indicator, which signals the endpoint. Right? You cannot see the endpoint without an indicator. And we also learned that the burette should be read from the meniscus. And at the endpoint, we assume that the moles of acid and base are the same. And then we also learned about the dilution equation, and we learned that we can determine the concentration or the volume necessary if we know at least 3 of the variables in the dilution equation.
Dun, 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 dun.